Good morning, children. So last class we have discussed up to what is mean by acid, what are the sources of acid, okay, physical properties and chemical properties, then uses of acids. Okay, so today we are going to start the next topic, role of water in acid solutions. Okay, suppose, so what is the meaning about role of water in acid solutions? Okay, so if you are taking acid, okay, mixed with water, so what will happen? It may split into ions. Okay, so H plus Cl minus, the same way, okay, water dissociated into ions, okay, H plus OH minus, okay, OH minus, okay, so what will happen? Cl minus, okay, this H2O, okay, joined with H plus hydronium ion. Okay, so in this way we will get the ions from where? In the solution form. Okay, the same HCl, okay, the same HCl mixed with organic solvent. So what are the examples of organic solvent? Methanol or ethanol. Okay, so we may mix with these acids, okay, HCl, nitric acid or sulfuric acid, mix with these organic solvents, okay, so it will not dissociate into ions, okay, that is called what ma? Immiscible, that is called immiscible, okay, here miscible, okay, this is what ma? Role of water in acid solutions. Okay, so they do not produce ions in organic solvents. Okay, for example, HCl dissolved in water, it produces H plus ions and Cl minus ions. Okay, so whereas organic solvents like ethanol, methanol, okay, do not ionize and it remains as molecule. Okay, remains as what ma? Molecules. Okay, suppose it may miscible also. Okay, so it will not split into ions. Okay, so next one, aqua regia. Next one, aqua regia. So what is mean by aqua regia? So aqua regia is nothing but what? It is a mixture of 3% HCl and 1% nitric acid. Okay, 3% HCl and 1% what ma? Nitric acid. That means what ma? 75 ml of hydrochloric acid and 25 ml of nitric acid. Okay, this mixture is called what ma? Aqua regia. Okay, suppose we may mix these two liquids. Okay, we will get what type of liquid ma? Yellow orange color fuming liquid. Yellow orange color fuming liquid. We have to mix with in what way? Optimally in a molar ratio 3:1. Optimally in a molar ratio 3:1. So what is the uses of aqua regia? Why we want to prepare the aqua regia? Okay, some of the metals, okay, it will not dissolve in acids. It will not dissolve in acids. Okay, for example, gold. For example, gold, silver, okay, copper, okay, platinum, okay, palladium. Okay, so these metals, okay, do not dissolve in acids. Okay, so how to dissolve? So mixing of these two acids, that is called aqua regia. So what is the uses of aqua regia? So we may prepare the aqua regia solutions. Okay, so with the help of that solutions we can able to dissolve these type of metals in this solutions. Okay, so gold, silver, copper, platinum, palladium. Okay, next one, uses of aqua regia. So what is the uses of aqua regia? So before that, physical properties are given. Okay, so chemical formula. What is the chemical formula? This is the chemical formula for aqua regia. What is the color? Yellow orange fuming liquid. Okay, solubility in water, miscible in water. Solubility means what ma? So whatever may be the ratio, we may mix with water. It is ready to mix with water. Okay, next one, melting point minus 42 degrees Celsius, boiling point 180 degrees Celsius. Okay, next one, uses. So what is the uses of aqua regia? Okay, first point, it is used to dissolve metals such as gold and platinum, noble metals. Okay, noble metals means what ma? Valuable metals. Okay, It is used for cleaning and refining of gold. Okay. So first one, it is used in where ma? Dissolve such a noble metals. Okay. Second one, it is used for cleaning and refining of gold. Okay. So next one, bases. Next one, bases. So what is mean by bases? So according to what theory? Arrhenius theory. According to Arrhenius theory. What is the spelling for Arrhenius? Arrhenius. 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 So according to his theory, substance that ionize in water. Okay, basis is nothing but what ma? Basis is a substance that ionizes in water to produce hydroxyl ions. To produce what ions? Hydroxyl ions. So that type of substances are the examples of what ma? Bases. Okay. So one more. Some of the metal oxides, okay, react with acid. Some of the metal oxides react with acid. For example, zinc oxide. Zinc is an example of metal. Okay, combined with oxygen to give zinc oxide, react with metal, hydrochloric acid. Okay, hydrochloric acid to give zinc chloride, plus water. Okay, plus water. So now how can we define the definition for bases? Okay, any substances produces, okay, OH minus ions, or some of the metal oxides are acting as a bases. Okay, so bases that are soluble in water called as alkalis. Okay, bases what ma? Soluble in water are called alkalis. So all alkalis are bases. But not all the bases are alkalis. Okay, can you understand ma? So already we have learned this one in where? Lower sections. Okay, so next one. So acid plus bases to give what ma? Acid plus base to give salt plus water. Okay, so this reaction is known as neutralization reactions. Okay, the same way, for example, for this equation, acid HCl, base sodium hydroxide to give salt. Okay, NaCl plus water. Okay, so based on this concept, okay, so we will define the definition for bases. Okay, so bases is nothing but what ma? A substance that ionizes in water to produce hydroxyl ions. This is one definition. Another one what ma? Some of the oxides which gives salt and water and the reactions with the acids. Okay, Okay, so bases contain one or more replaceable molecule of what form? Hydroxyl ions in solutions. Okay, so next one, classification of bases. So already we have discussed the classification of what form? Acids. The same way, classification of bases. Classification of bases. Okay, first one, monoacidic base. So already we have discussed in the acid what is mean by basicity. So basicity is nothing but what ma? In a solution, how many replaceable hydrogen? So according to this, we will define what ma? Basicity. The same way, acidity is nothing but what? The term acidity used for base, which means what ma? Number of replaceable what ions? Hydroxyl ions or hydroxyl groups present in one molecule of base. Okay, so if you are taking one molecule of base, how many hydroxyl group or how many hydroxyl ions are present. Okay, that is called what ma? Acidity. So, okay, monoacidic base. Monoacidic base. Okay, so it is the base that ionize in water. That ionize in water to give one hydroxide ion. Only one hydroxide ion. Okay, it is the base that ionize in water to give what ma? Only one hydroxide ion or hydroxyl group. Okay, in a molecule, that is called a monoacidic base. For example, sodium hydroxide and potassium hydroxide. Can you understand ma? Monoacidic base. Second one, diacidic base. Diacidic base means nothing but what ma? It is the base that ionize in water to give how many hydroxyl group or hydroxyl ions? 2. Okay, it is the base that ionizes in water to give 2 hydroxide ions per molecule. Okay, for example, calcium hydroxide and magnesium hydroxide. Okay, calcium hydroxide and magnesium hydroxide. Next one, triacidic base. Okay, triacidic base. Okay, so it is the base that ionize in water to give 3 hydroxide ions per molecule. Okay, that is called a triacidic base. For example, aluminum hydroxide. The same way, ferric hydroxide. Okay, this is what ma? One type of classification of bases based on what ma? Acidic nature. Okay, next one, based on their concentration. So based on their acidity, 3 types. Okay, next one, based on their concentration. Second one, based on their concentration. Okay, so concentrated alkali, another one is dilute alkali. Concentrated, another one is what ma? Dilute. Concentrated alkali. So what is mean by alkali? Bases dissolved in water to produce what ma? Alkali. Dilute alkali. Okay, so what is mean by concentrated alkali and what is mean by dilute alkali? Okay, in an alkali having relatively high percentage in aqueous solution. Okay, high percentage of alkali in its aqueous solutions. Okay, that is called what ma? Concentrated alkali. Concentrated alkali. So what is mean by dilute alkali? In an alkali having relatively low percentage of the alkali in its solution. So that is called a dilute alkali. Okay, here huge amount of alkali present in its aqueous solutions. Here less amount of the alkali present in its aqueous solutions. Okay, this is the second category. Okay, third category, based on their ionization. Based on ionization. So already we know what is mean by ionization. So ionization is nothing but what ma? It is the condition of being dissociated into ions either by what ma? Heat or thermal or what? Radiation or chemical reactions or electrical. Okay, so that is called ionization. So based on their ionization, 2 types. Okay, one is strong base. One is strong base. Another one is weak base. Okay, so what is mean by strong base and what is mean by weak base? Okay, these are all the bases which are ionized completely in aqueous solutions. Okay, completely ionized in aqueous solution, that is called a strong base. Example, sodium hydroxide and potassium hydroxide. Okay, completely ionized in where? Aqueous solutions. Weak base means what ma? Partially, that means what ma? 50% of ionized in aqueous solution. Example, ammonium hydroxide. Ammonium hydroxide. Okay, so that's all what ma classification of bases. Okay, next one, properties of bases. Properties of bases. So what are the properties of bases ma? Usually bases are in what taste? Bitter in taste. Okay, they are good conductors of heat and electricity. Okay, heat and electricity. Properties of bases. Okay, first one, what taste ma? Bitter in taste. Bitter in taste. Okay, second point. Okay, bases are what ma? Good conductors of heat and electricity. Heat and electricity. Okay, when they are in solution form. When they are in the solution form. Okay, next one, the turn red litmus to blue. Okay, red litmus to blue color. Okay, that is the third point. Fourth point, okay, bases react with the metal to form salt with the liberation of hydrogen gas. Okay, bases liberated with the metal, okay, NaOH, to give what ma? Salt and liberation of hydrogen gas. Okay, Na2 Z10O2 plus H2 gas. H2 gas. So what is the meaning about the fourth point ma? Bases react with the metals to form salt with the liberation of hydrogen gas. Okay, so fifth point. Okay, fifth point. Okay, bases react with the non-metallic oxide to produces salt and water. Salt and water. Okay, for example, calcium hydroxide. Okay, react with the carbon dioxide. Okay, calcium hydroxide react with the carbon dioxide to give what ma? Calcium carbonate plus water. Calcium carbonate and water. Okay, next one, bases react with the acid to form salt and water. Okay, that is called a neutralization reaction. Neutralization reactions. Okay, next seventh one, on heating with ammonia salt, bases give ammonia gases. Okay, on heating with what ma? Ammonium salt. Okay, bases give ammonia gases. For example, sodium hydroxide, ammonium salting, NH4Cl, to give what gas ma? Ammonia gas plus water plus what? NaCl. NaCl. Okay, so these are all the properties of what ma? Bases. Okay, last property, what property ma? On heating with ammonium salt, which one? Base to give ammonia gases. Okay, so these are all the properties of bases. Okay, next one, uses of bases. Uses of bases. So what are the uses of bases? Okay, first point, sodium hydroxide and potassium hydroxide are used in the manufacturing of what ma? Soap. Okay, soap and detergents. Okay, which type of bases are used? Sodium hydroxide and potassium hydroxide. Uses of bases. Okay, first one, sodium hydroxide used in where ma? In the preparation of soap. Okay, second one, calcium hydroxide is used in whitewashing of building. Okay, calcium hydroxide is used in where ma? Whitewashing. Whitewashing. Okay, third one, magnesium hydroxide used in where ma? Medicine for stomach disorder. Magnesium hydroxide. Okay, stomach. STOMACH. Disorder. Okay, fourth one, Okay, ammonium hydroxide is used to remove what ma? Grease stains from cloth. Ammonium hydroxide. Ammonium hydroxide. Okay, so these are all the uses of what ma? Bases. Okay, sodium hydroxide, calcium hydroxide, magnesium hydroxide, and ammonium hydroxide. Sodium hydroxide is used in where? In the preparation of soap. Calcium hydroxide in where? Whitewashing in the building. Magnesium hydroxide to reduce the pain in stomach disorder. Okay, ammonium hydroxide to remove the grease and some other pain material present in where? Cloth materials. Okay, next one. Test for acid and bases. Test for acid and bases. So this is the last topic of today class. Test for acid and bases. Suppose two solutions are given to us. How to identify which one is acid and which one is base? Okay. So how? So using the following test. Okay. So test for acids and bases. Okay. So with the help of litmus paper, so we can identify the given solution is acid or base. Okay, an acid turn blue litmus paper into red. Okay, an acid turn blue litmus paper into red, ABR. Okay, the same way base. Okay, base changed which one ma? Red litmus paper into blue, BRB. Okay, so in litmus paper, acid turn blue litmus paper into red, base turn red litmus paper into blue. Okay, so litmus paper is what ma? Like the small paper. Okay, we may take that paper, we may dip into the solutions. Based on the color change, we can identify the given solution is acid or base. Okay, second one, using indicators. So indicators is nothing but what ma? Already we have studied the definitions about indicators. It is a group of compound. Okay, we may add it into the solution of acid or base. Based on their color change, we can identify. Okay, based on their color change, what ma? We can identify the given solution is acid or base. Okay, so indicator is nothing but what ma? It is a group of compound showing some characters when we are adding into the acid or base. Okay, first one, phenolphthalein. Okay, so phenolphthalein, acid, there is no color. Okay, we may add the phenolphthalein to acid, no color. Base, pink color. Base what color ma? Pink color. Base, pink color. The same way, if you are taking the methyl orange. Third one, methyl orange. This is one type of indicator. Okay, in acid medium, okay, if you are adding the methyl orange, it will show in what color ma? Pink color. Okay, acid medium, pink color. Base medium, yellow color. Okay, so in this way we can identify what ma? The given solution is acid or base. Okay, so what are the methods ma? One is using litmus paper, second one using indicators. Okay, here two types of indicators are given. One is phenolphthalein, acid, there is no color, base, pink color. Okay, second type of indicator, methyl orange, acid, pink color. Okay, base, yellow color. Okay, so that's all. Okay, so the remaining part we will see in the next class. Okay, so today homework. Okay, continuous question number should be given. Okay, question number 5. Okay, question number 5. Okay, define base, full stop, give examples. Okay, question number 6. Okay, define aqua regia. Define aqua regia. Full stop. Give its uses. Okay, give its uses. Okay, second question, what question mark? Sixth question, define aqua regia, or what is aqua regia? Okay, full stop. What are the uses of aqua regia? Okay, next seventh question. Okay, seventh question. So, what are the properties of bases? What are the properties of bases? Okay, eighth question. What are the uses of bases? What are the uses of bases? Okay, so that's all. Today portion is over. Okay, so remaining part we will see in the next class. Okay, so thank you, children. Thank you.